Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you all about the new bottom-up parser technique, that is SLR parser. So let me tell you what is SLR. SLR parser is a simple left-right parser, which is the third technique we are going to see in bottom-up parsing technique, right? So directly I am getting into the topic. Now you can see here what are all the steps which can solve this parsing approach, that is augmented grammar, left right zero items, that is closure and go to function, we need to go with this, and parsing table as usual, and parsing input string, right? So these are all the four steps where you can able to see how exactly this SLR parsing technique can be solved, right? I'm starting with the first technique, first step, which is used to call as augmented grammar, right? So let me tell you what is this augmented grammar. Step number one, right? Now suppose assume that a grammar G is given, right, and the start symbol is yes. Say for example there is a grammar and the start symbol for this grammar is S. Now what is the augmented grammar for G is, right? So what is the augmented grammar? Whichever the new start symbol, say for example the start symbol, I said it is yes. Now you can say that the augmented grammar, this is a grammar, the augmented grammar for the start symbol is yes dash, right? So this is how we are going to find an augmented grammar in any given grammar, right? I hope you understand how augmented grammar has been approached, right? So assume that I'm going with an example, right? So now the example I'm going to take here is yes tends to, this is the given grammar, yes tends to capital C, that is a non-terminal, capital C tends to small c, capital C, and the third grammar is C tends to small d, right? So assume that this is a given example. This example we are going to take and we are going to solve how bottom-up parsing is exactly solved, right? So assume that I am going to take, this is row 1 and this is row number 2 and this is row number 3. I am going to explain all these rows when I am touching this parsing table, right? Right. So let us start with this step number 1. We all know augmented grammar, right? So this is the step number 1. Step 1. So now we have a grammar. The start symbol, you can able to see that yes is the start symbol. I already told you any given grammar, the start symbol, that new start symbol which has a protection has to be established. So I have shown you how exactly it was happened, right? Now step 1 we are going to solve. Step 1 we are going to take this S. So augmented grammar for this is S dash tends to S, right? I'm repeating the same with the start symbol is S, right? So let me write the remaining grammar. S tends to capital C, capital C, capital C tends to small c and capital C tends to small d. So this is step number 1, right? So let me take you to the step number 2. Now the step number 2 we have already given, that is left right of 0 items, right? We are going to have LR of 0, right? Take all those previous step. I am repeating that previous step here. So what is the previous step? S dash tends to capital S tends to capital C, and capital C tends to small c, capital C tends to D. So this is what the previous step we have been solved. Now we are going to add one particular precedence value, that is the parser precedence value will move from left to right. So I am adding everything in the beginning, just a dot. This is, we used to call it as precedence value. So this precedence value will move from left to right. So all these values will move from left to right based on LR of 0 item with go to function we are going to use. So I am going to take this as iteration number 0, right? So I am going to use now go to function, right? Let's solve this. Step number 2 is very easiest technique, right? So I'm going to use this go to. So I'm going to this iteration number. We need to mention what is that iteration number. That is iteration number 0. So I'm going to start with the first production here, and whichever the dot right side of the value we need to mention. So if it may be yes, it may be small c, small d, whatever it is, after dot whatever the symbol it is, that is what we are going to pass. So I'm going to start with this. So I'm going to pass capital S. Now you can see I'm going to take this s dash tends to. If I'm using this go to function, if I'm going to this capital S, that means we are calling this precedence value dot and we are accessing it. Whenever we are accessing it, it will move from left to right. So it will move here. Now you can see after dot there is nothing. So this is a new iteration. So I'm going to place that iteration as I1, right? In the similar way, I'm going to use the same iteration. Still iteration number 0 is not yet completed, so we need to parse all this production and then we move to the next iteration where there is an unsolved present value, right? So now again I'm using this go to function. Again I'm going to I0. The next value we have is capital C. So capital C. So what is capital C will happen? S tends to capital C. The dot will move from left to right, so it will move in the center, again a capital C. So which are all the left out over here? If it is ended here, we need not to call all the values in I0. If it is not ending, then we need to call all the left out production there. So the left out production in I0 is capital C tends to small c capital C, and capital C tends to small d. So this looks like a new iteration. So I am giving it as iteration number 2, right? So again we are using go to function. Still I0 is not over. So again I'm using go to function. Go to I0 comma small c, right? So I'm going here. This is small c. Previously we have gone there. This is capital C and this is small c. So most important part, we need to mention whichever the difference we have, we need to be very careful on that, right? So here we are going to it. Now we are using this function capital C tends to small c dot capital C. So here there is a process. Now whenever a parser identifies there is a terminal and a non-terminal, right? So this is a terminal term, this is a non-terminal term. So whenever this kind of parser, that is precedence value, has been placed in between terminal and non-terminal, then we need to expand. So this is a rule. So we need to expand. What is the meaning of expansion is repeat the same production without moving this production. I mean precedent, sorry. So we are going to use this C tends to capital C. Again C tends to small d. So this is how this particular rule works. Now this is going to be a new iteration number 3, right? So still we have one more production has to be moved in I0. Still we are in I0. So again I'm going to I0 comma small d. Now small d, you can see that it is going to be an n because C tends to dot will move here. So there is nothing has to be done over here after this dot. So I am ending up this particular process with iteration number 4. So after moving all these values, so all these items, that is all the production in I0 has been completed. Once it is completed, I need to move to next iteration. This is how the cycle works. I need to move to iteration number 1. If I move to iteration number 1, I need to see what is the next value after this dot. This is nothing. So what I need to mention is, so we need to take this process, go to, that is go to, I'm going to I1, but I1 has nothing to be moved, then we have to mention it as null, right? So in the similar way, I'm going to iteration number 2. So you can able to check that. So we have an iteration number 2 here. You can see his. We need to move to this dot, this precedence value, that is capital C, after the small c, after a d. One by one we can able to move that, right? So this is how this particular process works. So now I am moving to iteration number 2. So each and every process has to be followed in the similar particular way.